In this problem we're given 6 different types of equations, and our job is to simply solve each one of them. The first one is a rational function, and since the x is being divided, one thing I can do is multiply both sides of the equation by x, so that would be 1 over x times x, and then since I did that to the left hand side, I must multiply the right hand side by x as well. Normally I caution students about multiplying by variables because whatever expression you multiply, whatever makes that expression 0, you're potentially introducing that solution to the equation even though it's not there. But in this particular case, x cannot be 0 in the first place because the fraction on the left side of the equation would be undefined. So I'm going to say on the left hand side, things will simplify out just to give you the number 1. And then to finish solving, since the 5 is being multiplied, I will simply divide both sides by 5. And then by doing that, the 5 simplify on the right hand side, giving me that the solution is x equals 1/5. The second equation is a square root equation, and I know the inverse of taking the square root is to square. We should be fine in this context squaring both sides, but whenever I square both sides of an equation, I caution students that squaring both sides of an equation can give a solution that doesn't check. But in this case, things will work out. As you'll see, the square root and the square simplify down just to be x on the left side, and on the right side you get 64. If you were just to check it by plugging 64 into the equation here, you'd see that you get the square root of 64 equals 8, and since the square root of 64 is equal to 8, that's a true statement. That makes x equals 64 a valid solution to the equation. Our third example is exponential. I noticed that it's a base e exponential, so if I were to simply plug the left side of the equation into the natural log function and do that with the right side as well, that the left side was simplified down. The ln of e to the x is simply just x, because you have a base e exponential composed with a base e logarithm, and exponentials and logarithms of the same base are inverses of each other. So I get that x is equal to the natural log of 10. If you were to check it, you'd get e to the natural log of 10, which is indeed 10. That's a true statement. Again, you've got a base e logarithm composed with a base e exponential. They're inverses and they cancel, leaving you with 10 on the left-hand side. Our next example has us taking x to the 5th to give you 18. The inverse of the 5th power is the 5th root. In general, if you have x to the nth power, the inverse would be the nth root of x. So since this is the 5th power, I will take the 5th root of both sides. So I plug the left side into the 5th root function, and I plug 18, which is the right side of the equation, into the 5th root function. Or you can think of it as you're taking the 5th root of both sides. On the left-hand side, since this is an odd power, I get that it simplifies just to be x, and on the right side I get 5th root of 18. It is noteworthy that if it had been an even power that x was being raised to, that when you take the nth root, that the left side would not simplify down just to be x. It would simplify down to be the absolute value of x, in which case you'd get two solutions, positive 4th root of 18, and also the negative 4th root of 18. And there are a couple different ways you could type this into your graphing calculator. So if you needed a decimal approximation to the 4th root of 18, you could press the number 4, the math key, select option 5 for the xth root, and type in 18. Then you could do the same for the negative 4th root of 18. Alternatively, since exponent rules say that the 4th root of 18 is the same thing as 18 to the 1/4 power, since the power on the 18 is a 1, and the exponent rule has us taking the power and dividing by the index of the radical. So you could have typed in 18 raised to the 0.25 power, or if you want 1/4, and get the same answer. I'm going to leave my answer in exact form because the directions did not indicate that it wanted me to approximate the answer in round. If you're doing this problem and more, the question is currently coded so that you want to type your answers in exact form like you see here. In fact, you type them in simply separated by a comma. And by the way, you should still get credit if you were to type them in reverse order. So in more, when you click in the answer box, you should see an icon that looks like this, and clicking it will help you type in your answer. The next equation is a logarithmic equation, and given its simplicity, to solve for it, you can simply change the equation from log form to exponential form. For example, the 3 would be the base when written in exponential form, and if you take 3 and raise to the negative 5th power, you are to get the variable x. So I've already solved for x. You could write your answer as 1 over 3 to the 5th if you wanted to write it without negative exponents. And since 3 to the 5th is 243, I'm going to write my final answer as x equals 1 over 243. Finally, we have the cube root equation. Cube root x equals 4. The inverse of taking the cube root of something is to cube it. So I'm going to cube both the left and the right side. On the left side, the cube root and cube simplify out, so I'm left with the radicand, which is just x. And I have 4 to the 3rd. And 4 to the 3rd is simply 64.